Hey guys, hope y'all are doing well. Hope you're having a good weekend. Go ahead and make sure you've got your book out. We're starting section 3.5 on page 207, and we're going to be talking about proving lines parallel. So we're still going to be using the two-column proof format that we talked about last Thursday and Friday in class, but now we're moving away from the algebraic side of things and moving more into exclusively geometric proofs. Okay, so we're going to be going back and looking at a lot of these postulates from the last unit, where we had two parallel lines being cut by a transversal here, and we had certain relationships that existed. But we're actually going to be looking at the converse of that in this particular section. Okay, so before, what I was given was that I had parallel lines to begin with. And based upon that, there were certain relationships that existed. One of those relationships being corresponding angles, which are all listed here. So the converse of that is, if I know that these angles are congruent, okay, so 1 and 3, for instance, if I know that these two angles are congruent, then I can tell you that the lines are parallel. So it's kind of going the other direction. And each one of those relationships that we talked about in that particular section, I think it was section 3.3, if I remember correctly, where we talked about corresponding angles, alternate interior, alternate exterior, all those relationships. Every single one of them has a converse like this. So again, before, I'm starting with the given fact that the lines are parallel, and based on that, I have these relationships that exist. Now what I'm saying is, if I have two lines that are cut by a transversal, and I can say that these two angles are congruent, then I can say that the lines are parallel. Or if I can say that these two angles are congruent, then I can say that the lines are parallel. Or if I can say that these two are congruent, I can say the lines are parallel. Or these, I can say that the lines are parallel. And that's the converse of the corresponding angles postulate. So make sure you get that jotted down, and we'll go through the next few slides here, and I'll briefly explain the rest of the converse postulates, but they're all basically the same. Okay, before I started off with, I know that the lines are parallel, thus the angles shown here are congruent. Now I have two lines being cut by a transversal, and if I can prove that these two are congruent to one another, then I've proved that the lines are parallel. Okay, so very, very similar to before. I'm not starting with parallel lines anymore. I'm proving that the lines are parallel based upon the fact that I have congruent angles. And then if I could also prove these two angles were congruent, then I could say that the lines were parallel also. And that's your converse of the alternate interior angles theorem. Okay. Very similarly, we had the consecutive interior angles theorem that said, if I have two parallel lines, then two interior angles on the same side were supplementary, meaning they add to 180 degrees. So 1 and 2 would add to 180, 3 and 4 would add to 180. Now what I'm saying is, if I have two lines cut by a transversal, and I can prove to you that these two angles, these two interior angles on the same side of the transversal, are supplementary, then I'm proving that the lines are parallel. And that is your consecutive interior angles converse. Okay, so make sure that you get the converse of that jotted down. You should already have all of these postulates and theorems from before in that graphic organizer somewhere. And if you've lost that, then I can get you another blank copy, and you can fill that back out. But make sure that you are pausing these slides long enough to get these converse theorems jotted down. We are going to be using the converse of these theorems in our proofs. And then our last one here, the alternate exterior angles theorem, starting off with two parallel lines. If I know the lines are parallel, then I know 6 and 8 are congruent. I also know 5 and 7 are congruent. Okay, so the converse of that would be I have two lines cut by a transversal. If I can prove to you that these two angles are congruent, then I'm proving that line P is parallel to line Q. Also, if I can prove to you that these two angles are congruent, then I'm proving that line P is congruent to line Q. Okay, so this is in your section, in your book, in section 3. Whatever this section is, 3.5 I believe it was. So make sure you get all these converse theorems copied down before moving on and working these next few examples. Okay, so we're going to right now just kind of work on the thought process. This isn't going to be a formal 2-column proof, but we are going to prove lines parallel and state the postulate or the theorem that we're using to make our claim. Again, not in a 2-column format right now. We're just kind of working on the thought process of what's going on here. Okay, so given the following information, in this particular example, our given information is that angle 1 is congruent to angle 6. The first thing I want to do is I want to determine, if you'll notice here, I have 3 lines being cut by a transversal. So what I need to do is I need to narrow it down to what lines am I actually looking at. I'm sorry, not angle 3, angle 6. Okay, so there's the 2 angles that I've been given. So the only 2 lines that I'm really concerned with are this one and this one with my transversal here. Okay, so this middle line becomes insignificant. I don't care about that. I'm only looking at line L and line N with transversal P. Okay, so I want to categorize these 2 angles in relation to lines L and lines N being cut by transversal P. And what kind of angles would they be? Well, they're on the outside and they're on opposite sides of the transversal. So they're exterior and they're alternate. So yes, they are alternate exterior angles. So how can I use that information to show that the lines are parallel? Well, they told me that these 2 are congruent. We know that they're alternate exterior. So I can use the converse of the alternate exterior angles theorem and state that because these 2 are congruent, I know that line L is congruent to line N. And you'll see the statement made here. Since they are alternate exterior angles, and I know that they're congruent, line L is parallel to line N by the converse of the alternate exterior angles theorem. And this is the way that I want you to write your responses here. Okay, this is not in a 2-column proof format. This is more of an informal type proof. You have one statement telling me what the relationship between the angles is, and then the second statement that's kind of your proof statement. Okay, since they're congruent, they're parallel, and then tell me what theorem or postulate is that you're using to justify that claim. Well, let's look at another one similar to this. A same given figure here, but now I'm telling you that angle 2 is congruent to angle 3. Okay, so first of all, I want to narrow down what lines am I dealing with. Okay, so there's my 2 angles. So I would be dealing now with line L and line M and transversal P. So now all of this down here becomes insignificant. I'm only worried about what's going on up here. So what would the categorization of angles 2 and angle 3 be here? Okay, they're on the inside, making them interior. They're on opposite sides of the transversal. So they're alternate interior angles. So if I know that alternate interior angles are congruent, I can say that the lines are parallel. So again, I've got my 2 statements that I'm going to make here. My first statement, what are they? And then my second statement, since they're congruent, what lines are parallel? L is parallel to M. And then what did you use as far as a theorem to make your claim? Okay, so tell me what's the relationship, and then based on that relationship, what do I know? All right. So now let's do a few of these together. And I do want you copying these examples that we're doing together down. All right, so same figure, different angles given to me. So the first thing I want to do here is figure out what lines am I dealing with. There's angle 2 and angle 8 is not shown in the figure. So we're going to say that angle 8 is located, this was 6, probably be, let's call angle 8 right there. Okay. I don't know if this is a typo or what, but we're going to call angle 8 that angle right there. So let's figure out here which lines we're dealing with. We've got line L, where angle 2 is. We've got line N, where angle 8 is. And then here's my transversal P. Making all of this stuff in the middle insignificant to me. I'm only concerned with line L, line N, and line P. Okay, so now what I have is two interior angles that are on the same side of the transversal. Okay, so the first thing that I want to write is angle 2 and angle 8 are what kind of angles? Well, if they're on the same side of the transversal, they're going to be consecutive and not alternate. So consecutive, angle 2 and angle 8 are consecutive interior angles. Okay, well, what does that tell me? I know that their relationship is consecutive interior, and I was given that they're congruent. So now that I've stated the relationship, I can say since angle 2 is congruent to angle 8, what do I know? I know that this line and this line, L and N, are parallel. And what did I use? By the converse of the consecutive interior angles theorem. Okay, and you can abbreviate any of this that you want as long as I can still understand what it is that you're saying. Okay, don't abbreviate it so much that I can't figure out what the words are that you're abbreviating. Okay, so define the relationship and then make your claim, and then tell me what you used to make your claim. Okay, let's look at another one. And again, we are missing angles. So I am going to just place this where I see fit. Okay, so let's call this angle 3, and let's replace angle 6 with angle 11. Okay, so now that we know what angles we're dealing with, I've got this guy and I've got this guy. I can narrow down what part of my figure I'm actually concerned with. Okay, so here is one of my angles, there's my other, so line M, line N, and again my transversal is going to be P. So don't care about any of this with line L, only concerned with these two lines. So the first thing I need to know is, what's the relationship between angle 3 and angle 11? Well, they're on opposite sides of the transversal, so I know they're going to be alternate something, and they are exterior. Okay, so I know that angle 3 and angle 11 are